Hello, everyone. Last week, we had a problem about fundamental theorem of calculus, and Hossein helped me to solve part A of the problem. How are you, Hossein, today?
I'm good, thank you, Amijin. How are you?
Good, thank you. And yeah, last week you solved part A. I'm
Right.
excited about part B and C. I'm sure you are also excited.
Yes, yes.
Yes. So it was about fundamental theorem of calculus. As I said, we have g of x, and you see the integration. And in the graph, you have the function f.
Right.
For part B, you need to find absolute maximum of g of x.
Okay.
So the floor is yours.
Okay. Yeah, just to remind everybody what we did last week. So we had a function of g of x in terms of f of x defined on the first line, and then part A was to find local max and local mean. And as you can see here, from calculus, we know that local max happen when the derivative change from positive to negative, and the local mean happen when derivative changes from negative to positive. And from fundamental theorem of calculus, we know that g prime of x is equal to f of x. This is what I wrote on the last line here. And so using these two, I was able to look at this graph and find the local maximum and local minimum of the function g. So basically, we said this f of t is the derivative of g, and then whenever the sign of g, the sign of f change from positive to negative, like this point, and then we said we have a local max, and then when the sign changed from negative to positive, we said we have a local mean.
Great.
Now part B is asking for the absolute maximum of G. So we have several local max, like this point here, and this point here. We wanted to see which one is absolute maximum, which one is the largest
one.
Maximum,
yes.
Right? So I want to use actually I want to do the integration because for example, let me actually label these points. So let's call this point P1, and then the second maximum, let me call that P2, and then this is P3, and so on.
Yes, you are just looking at the maximum points, not the minimum.
Right.
We don't care about the minimum points. Correct.
The same rule applies if the question was asking about absolute minimum of G.
Minimum.
Right. So at P1, I wanted to actually calculate the value of G. So to do that, we use integration. So let me show it on the graph first. So P1, we know that f of t, this graph that we see, is the derivative of g. And if I wanted to find the value of g at P1, I need to do integration. And basically, integration means the area under the curve.
Yeah, the area, correct.
Right. As you can see on the first line here,
yes,
g of x is it defines from 0, and I wanted to, for the upper limit of the integral, I wanted to use P1 as the upper limit. So I'm going to calculate the area under the curve from 0 to P1, which is this area that I'm shading here.
Yes.
And let me call this A1.
Yes. You look at that qualitatively because you don't calculate quantitatively. You just,
Exactly. Yeah, we don't know
yeah.
exactly where P1 is happening in terms of at
The
what
x-axis, yes.
x-axis or
Yes.
t-axis. But
Yes.
I'm saying that the value of t, if we wanted to calculate, it's going to be this integral from 0 to P1.
Correct.
So I'm going to write that down here. So P1, let me see, G at P1 is equal to 0 to P1 f of t dt.
Yes.
Yeah. And then this is,
And
as I have shown on the graph, it's going to be A1.
Yeah, area under the curve. Yeah.
Right. And then moving to the next point, P2, I have, so P2 is here, then I have to add more area to A1 because I have to do integration from this point t equals 0 to this point t equal P2. So the area I need to add is this area and this area. So I'm going to call this area A2, and I'm going to call this area A3. So the reason I use different colors is that this area is under the t-axis, so it's going to be negative. It's going to be subtracted from A1, and then this area is positive. It's going to be added. Now I'm moving down here. So G at P2 is equal to the integral from 0 to P2 f of t dt, which is equal to A1 minus A2 plus A3. And so we know that A1, from the graph, we know that A1 is greater than A2, A2 is greater than A3.
Yes.
So as a result,
when you look at the graph, you can see that. Yeah.
Right.
The curve is actually experiencing attenuation. As t increases, we have like attenuation, like damping curve.
Exactly. And then so as a result, I can say this the second term is less than G at P1. And then moving to the third point right here, I have to also calculate two more areas. One is here, which is A4, and then another one is here. I'm going to call it A5. So
correct.
So G at P3 is equal to integral from 0 to P3 f of t dt, which is equal to A1 minus A2 plus A3. And then if we look at these two new areas, this is going to be subtracted and this is going to be added. So I have minus A4 plus A5. And I know A1 greater than A2 greater than A3, and then A3 is greater than A4, A4 greater than A5.
Mm-hmm.
then I can say this is less than G at P1 definitely. So as we see here, when we move down the t-axis, the area under the curve is getting smaller and smaller, and then the value of G at these local max, it's getting smaller and smaller. So the maximum value
Yes.
happen at P1, and then the value of G at P2 is smaller, the value of P3 is
Yeah.
smaller than P2 and P1. So to answer the second part, the part B of the question, which is asking the absolute maximum of G, so based on what I explained, the absolute maximum happen at P1.
Yes, that's correct. And the reason is that, for example, A2, which is blue here, is greater than A3, and the area.
Right.
Area for A4 is
Mm-hmm.
also greater than A5.
Right.
So you know that you are subtracting a larger value than you adding a value like A3.
Right.
So that's why actually you see that A1 is greater, than
Right.
all other terms that you are adding or subtracting.
Right.
Uh, so yes, that's correct. So the maximum absolute happens at P1. Thank you,
Right.
Hussein.
All right.
And yeah,
So
part C,
okay.
please.
Yeah, part C. Let me see. Part C is asking for the intervals that within those intervals G is concave down. So
Mhm.
to find if a function is concave down or concave up, you need to calculate the second derivative of that function.
Yes,
So the second derivative of, let me write it down here. So the second derivative of G of X is actually the first derivative of f of X.
correct. Because G prime is equal to F, then
Yes, because G
yeah,
prime is equal to f of X,
based on the actually the fundamental
fundamental
theorem
theorem
of
of
calculus.
calculus, right?
Yeah, correct.
So the second derivative of G is the first derivative of F.
So we are looking for G double prime of negative. So G double prime should be negative.
Right,
Yeah.
right. So concave down, it means G double prime of X should be negative, and then because G double prime is F prime of X, so we're
Yes.
looking at the intervals where F prime of X is negative, and
Yes.
we know that F prime of X is actually a slope
The slope of the curve. Correct.
of the tangent line,
Yes.
tangent
Yeah.
line to the curve. So if we go back to the curve,
So we have to look at the intervals where F is actually descending.
um, right. So I'm
Yeah.
going to draw a tangent line here. So for example, the
Yeah.
tangent line here is downward, is negative. And
Yes.
then here in this area, tangent line is positive,
Positive.
right?
Correct. Yes.
So I can say from 0, like from this point to this point, the
Tangent line is
the
actually negative.
the tangent line is negative. As a result, g of X is concave down. So
Yes,
I'm going
that's
to
correct.
write that down. So this is the interval that g of X is concave down.
Yeah. And in that interval, actually, f of x is actually uh, descending. or decreasing when you move from left to right.
And then, so this is not the only interval that G is concave down, because if we move down the curve, we see that there is like the slope here is negative. That's why from here to here, this is another interval that G of X is concave down.
Correct.
And then same here, because the slope here is negative, I have another interval here that within that interval, G of X is concave down.
That's correct, yes.
And so on.
You can actually go to infinity with that.
Yeah.
Correct. So the concept is wherever f, the tangent of f is negative, you have G as concave down.
Right.
So yes, thank you, Hussein, for solving 3 parts of this problem. As you can see, the viewers can see that this problem is like a qualitative illustration of the fundamental theorem of calculus. We didn't obtain any specific value or number by solving the integrals. We just showed that how you can look at the area under the curve and interpret it as a value to estimate the absolute maximum or the local max or local mean, or the intervals regarding the concavity or convexity of the function. So hopefully you learned something from this problem. And if you like the video, please subscribe to our channel and hit the notification bell. And yes, until the next video, take care and cheers. Thank you, Hussein.
Thank you. Bye, everyone.
Bye.